Hi students, this is Mr. Patrick Ang, and this video is on energy and work done for Site 1 Science. Yeah, like always, you need to have your notes with you to be filling up the notes and going through whatever that's on the slides. So for this video, we're just covering work done. So it's just there'll be two main key ideas you need to know. So when we talk about work done, it's slightly different than how we usually say it in English, usually in daily life. So in physics or in science, the idea of work done is very specific. So here when we talk about work done against gravity, do you know it's actually the same if you climb a mountain vertically up or walk along a gentle slope to the top. Okay, even though it may be easier, but actually it takes a longer time. So in terms of work done, it's actually the same. So this is the part that we have to understand what work done really is. So work is done when there is a force, and the force causes an object to move in the direction of the force. So what do I mean by that? Here you need to take note that it is not just about doing work, like doing your homework or doing your parents going to work. This work done is talking about the force causing an object to move in the same direction. Okay, so we have 4 examples to the notes. I want you to take some time to look through these 4 options and then make a prediction by yourself. Do you think there is work done in each of the example? So you can pause the video, just take 1 minute to try and circle yes or no, and then you can continue the video to see if you're correct or wrong. Okay, so do not be lazy, just pause and then try it out. Okay, so I guess you are done, so let's move on. So the first one is lifting a book from a table. So when we want to consider lifting a book from a table, where is the force acting? So if you identify it correctly, the force is acting upwards because you're lifting the book up. Okay, so where did the book move? The book moved actually in the same direction, it moved upwards. So you see in this case, right, the force and the distance moved are in the same direction. So in this case, there is work done. Okay, so for part A, there is work done. The second situation, we have a book lying on the table. The question is, if a book is lying on the table, nothing is touching it, is there a force acting on it? Well, if you learned it in the previous chapter on gravitational force, you will know that weight is a force. And so there is a force acting downwards due to gravity. So this force is acting downwards. However, is there any distance move because of this force? Well, the answer is no, because the book is still lying on the table, it's not moving anywhere. And so because of that, even though there is a force, there is no distance, so there is no work done. There is no work done. Okay, the third situation, where you have a book, pushing a book across the table. Now I want you to, if you haven't been doing that, please pause and try to draw the arrows now. Figure out where is the force and where is the distance moved. Alright, so if you've done it correctly, it should be looking like this. When you have a force, in this case I will push to the right since there's not space to the left. I'll push to the right, and then the force is toward the right. Where is the direction move? Where is the distance move? Okay, it is also to the right. It's the same direction as my force. So in this case, there is also work done. So for part C, there is work done. Now the fourth one is something interesting. Okay, I am holding a book and I'm walking forward. Is there work done in this case? Okay, first you need to identify where is the force now. Now we know there's a force acting downwards due to weight, but to hold a book, where is the direction I'm acting on? Okay, I'm actually lifting the book and holding the book, so the force is actually acting upwards. Okay, the force is acting upwards because I'm holding on to the book. But as I'm walking, am I walking upwards? Is the book going upwards because of that? Well, not really. When I walk forward, right? So the distance moved by the book and by the person is actually forward. So in this case, you see that the force and the distance are not in the same direction. The force and the distance move are not in the same direction. So in this case, there is no work done, even though there is a force, there is a distance. Okay, there is no work done in this case. So let's review. So we have went through 4 situations and we kind of know that part A and part C there is work done. For B and D there is no work done. So in the same way, let's say if I am pushing against a wall, okay, I use a lot of force to push the wall. But if the wall is not moving, am I doing any work? Okay, so if the wall is not moving and I'm pushing against the wall, I'm not doing any work. There is no work done because there's no distance moved. Alright, so I hope that this is something clear for you. Okay, if you still have questions, you can ask your teacher in class. Okay, so can you think of more examples? I think we can discuss that in class. Alright, so the next part you need to know, now that you know that there is force in the direction of the distance moved, the next thing you need to know is the formula. So this is important when it comes to calculating like what is the work done, or when you want to calculate force or distance, depending on what you're given. So in case the formula is work done equals to force times distance. Okay, force times the distance moved in the direction of the force. This is not any distance, this is the distance in the same direction as the force. Okay, so force times distance. Work done, the unit for work done is joules. Okay, for the unit for work done is joules. And if you take note, the unit for work done is joules, so the unit for force is Newton, the unit for distance is meters. So if it's not in this, if it's not in Newton or not in meters, you need to convert. That only that way then you can get joules. So if you see here, joule is equivalent to 1 Newton meter. Well, that makes sense because force is Newton, distance is meter. I multiply Newton and meter together, I get Newton meter. But usually we don't use this unit, we use joules for work done. Okay, so now we have 4 examples. Again, it'll be good if you can pause the video and then try by yourself before going through the answers here on the video. Okay, so for example 1, okay, I have a force acting that's 12 newtons and I notice that it is weighing 12 newtons, so it's acting downwards. Okay, I'm lifting the book, so I need to use 12 newtons to lift it up. And I lift up a height of 1.2 meters. So how much work did a girl do? Okay, I put the formula, W equals to F times D. I put in the numbers. 12 Newton is my force, which is acting upwards to lift the book. And 1.2 meters is how far the book has went. Okay, I multiply, I put in my calculator, I get 14.4 joules. So make sure that your unit is correct. So that's for example 1. Alright, so make sure you do the other 3 examples first before you go through the video. Okay, let's move on. So here in this case, I have a strong man this time with a force pulling a truck. Okay, it pulls it for 20 meters. Well, this is more obvious because there's a force, there's a distance. Again, how much work is done? It is very straightforward. Formula, substitute the numbers correctly. This is the force, this is the distance moved. Check if the distance is in meters. In this case it is, so I don't need to convert. And multiply, put in calculator, my answer is 70,000 joules. Okay, so this is very simple. Just to make sure how you know how to use the formula. Okay, example 3 is slightly different now. Now I have a boy pushing a science textbook across the table with a force of 25 newtons. And instead of telling you the distance moved, the question tells you the energy that's been, the work done. Okay, work done by the person. So how far did the book move? Okay, so I can still put in the same formula to find distance moved now. Okay, I put 12.5 as my work done, 25 as my force, and my D, since I do not know my D, I leave it as D. And then I arrange it such that I can divide. Okay, so this is multiply, so throw over is divide. I have 12.5 divided by 25, and I get 0.5. Again, because when I use this formula, this is in joules, this is Newton, therefore my answer will be in meters. Okay, so the answer is in meters. Okay, the last example, we are ending soon. So a strong man is pushing against hard on a brick wall with a force of 1000 newtons, but fails to move it. So how much work is he doing? So in this case, I've mentioned just now, if the wall doesn't move. If the wall doesn't move, distance moved is 0. Okay, so if distance moved is 0, then naturally anything times 0 gives me 0. So the work done here is 0 joules. The man is not doing any work, even though he's strong. Alright, so that's the end for this video. Okay, if you have any questions, again, write it down, bring it to class. That's all.